tumbling down, pledging their love to the ground. Lonely but free I'll be found, drifting along with the tumbling tumbleweeds. Cares of the past are behind.
California is expected to experience a 3% increase to a 22% decrease in average precipitation by 2100, along with an increase of average summer temperatures of 4 degrees to 15 degrees Fahrenheit, and more frequent extreme heat events. Long-term weather is difficult to predict, and many doubt the results of climate models and scientific research which projects gradual warming and future water scarcity in California. Regardless, California's current drought illustrates the need for adaptive practice in agricultural production. By understanding the potential effects of climate change in the environment, producers can better assess their preparedness, anticipate future challenges, and adopt new practices to maintain sustainable production for themselves and future generations. Higher levels of atmospheric CO2 and rising temperatures may increase yields initially by lengthening growing season, increasing growth rate, and providing more carbon for respiration. However, too much increase in heat is likely to create many difficulties. Increased temperatures and longer seasons will mean that weeds, insects, and disease pests begin their life cycle earlier and are able to grow and reproduce for longer periods, as well as exist in areas where cold temperatures have limited their spread in the past. These increased pest pressures, along with stress from extreme heat events, may affect both crops, livestock, and farm laborers. Increasing winter temperatures would reduce the number of chill hours, which allow for sufficient dormancy of crops, promoting healthy blooming, fruit set, and potential yield. Among California's crops most affected by reduced chill hours are cherries and almonds, and while annual crops may benefit from warmer cool season conditions, none of California's 20 most valuable perennial crops are projected to experience benefits from reduced chill hours. Increasing average temperatures also means California would receive less precipitation and snow, decreasing surface water by melt, and increasing reliance on groundwater. California is the only western state without regulations on measurement of major use. However, most monitored areas of the state are observing record low groundwater levels, with much of the San Joaquin Valley experiencing levels over 100 feet below historic lows. Many agree that the investments and services made by California's agricultural producers justifies the increased translocation and pumping of water resources. Many rural communities are centered around agriculture, and so to simply cut off their water, as many would like to do, would be a disaster for those local economies. Instead, California's agriculture industry must approach climate change with adaptations through short and long-term practices, improved technology, and resource management policy, all in order to maintain agricultural prosperity in the coming years and future generations. The most immediate concern to many of California's producers is water availability. Through employing water-saving irrigation technologies, increasing water storage and conveyance efficiency, and implementing local water conservation plans, water can be allocated where it is needed most. In addition, experts suggest increasing measurements of groundwater pumping, reducing inefficiencies in policy and infrastructure of surface and groundwater trade, conducting more in-depth economic and environmental evaluations of groundwater, and maintaining detailed management of groundwater data. Planting perennial crops in appropriate regions with respect to their optimal temperature ranges, crop lifespan, and the projected regional climate change will allow production of full potential yields. Central to this effort is the identification and development of adaptable commodity species. Research in GMO crops may continue to produce cultivars specifically engineered for drought tolerance and pest resistance, and through publicly funded research, these GMOs may serve California's farmers without increasing reliance on synthetic inputs prescribed with corporate GMO crops. Increased monitoring for pest species, research for new methods of control, and support for biodiversity in the state's ecological systems will also help to control pest pressures. Perennial crops require long-term investment, significantly increasing the risk of drought impact within their lifetimes. Farmers are advised to irrigate consistently throughout the growing season and to partition water to younger, less consumptive blocks of trees. Overall, best management practices to sequester carbon in soils will increase fertility of the soils, increase their water holding capacity, and is capable of offsetting 5 to 15% of fossil fuel carbon emissions associated with future climate change. California's soil is among the most rich in the world. Regional cropping systems have been developed to meet the potential of these soils over generations, and making changes to more drought-tolerant production will not be an easy transition. We can continue to hope for the best, but we are likely to face many climate problems in the years to come, and the sooner we prepare, the better we will adapt.